Hello everyone, my name is Mvita. In today's talk, we'll focus on amazing water. But before we dive into today's talk, I'm going to briefly take you through what we have learned so far and where we are currently in our hierarchy of models. We first started off with the Earth as a bare rock and found out that the distance alone from the Sun would make Earth too cold to be habitable. We then expanded on our bare rock model and added a static atmosphere which made Earth to be too hot. We then added a circulating atmosphere and circulating oceans to our model, which resulted in the Earth's temperature being just about right to make the planet habitable. However, a circulating atmosphere and circulating oceans are not the only parameters needed to make our planet habitable. In the previous core talk, we introduced life into our model and investigated the origins of life, and in this talk, we'll investigate the prerequisite condition for life. In earlier talks, we spoke about how the Earth maintains the right temperature. But why is the right temperature so important? One of the main reasons is that it allows for the presence of liquid water. Well, liquid water is important because it is the only prerequisite for life. A liquid is defined as a substance that is not solid or gas, and it can easily be poured into something else. Importantly, we need to remember that without liquid water, there would be no life. In this talk, we are going to start off with a brief history of the right condition for life, where scientists thought that they discovered the prerequisite for life, but that theory was falsified when they later on discovered the existence of extremophiles, which are organisms that can thrive in extreme conditions. They then went back to research and found out that liquid water was the only prerequisite for life. Well, later in the talk, we'll try to answer the question, why liquid water? Well, to answer this question, we'll have to break it into two parts. The first part will investigate why the liquid phase is the only medium that can sustain life. Well, that is because the liquid phase is able to pass on genetic information from one generation to another. The second part of the question will find out why this liquid has to be water. This liquid has to be water because water's unusual chemical structure gives it unique properties that enable liquid water to contribute to making our planet habitable and in sustaining life. We will end this talk by looking into how water is able to constantly recycle itself through the Earth system via the hydrological cycle. Without the hydrological cycle, we'd run out of water, which is essential for life. Although South Africa is known to be a water-scarce country, it does have vast oceans and rivers, as well as amazing water-based tourist attractions. Well, let's dive right into the talk by discussing the conditions that make Earth habitable. We are going to start off by briefly investigating the prerequisite for life. Prerequisite for life basically means something that is required as a prior condition for life to exist. It's more like how you need to pass your semester 1 modules for you to be able to register for your semester 2 modules. Because if you don't pass, you will still be in first year till today. Well, if we do a bit of history and rewind to the 1960s, scientists thought that they found the prerequisite for life. Scientists thought that for life to exist, it had to be not too hot, not too cold, not too alkaline, or not too acidic. This is because scientists thought that all these conditions would destroy a biological cell, but they discovered something that would change their theory forever. Well, in the 1970s and 80s, something amazing happened and changed the previous theory. Scientists found organisms called extremophiles, which are organisms that can survive in extreme conditions. Look at this for example. They discovered species called thermophiles, which are organisms that can thrive in extreme temperatures as high as 60 degrees Celsius. Psychrophiles that can survive in very low temperature as low as negative 20 degrees. Halophiles that are salt-loving and thrive in conditions that have high salt concentration. And then acidophiles that can thrive in very high acidic concentrations because they like acid so much. So, since these species were discovered, the previous theory on the prerequisite of life was falsified because it doesn't seem to be any limit on temperature, acidity, or alkalinity. So, scientists had to go back into the lab and investigate the extremophiles and other living organisms. They discovered that there's only one thing that all the living organisms have in common. there's one amazing substance that is a prerequisite for life. Without this amazing substance, there would be no life. Can you guess what that amazing substance is? Yes, you guessed that right. The common substance is liquid water. Liquid water is the only thing that's made possible for all living organisms to strive regardless of the conditions. I am sure that you have questions. Enoch, how are you introducing water into our model while we don't know how Earth got its water? Don't worry, don't worry. I got you. So, throughout this talk, we have demonstrated that liquid water is a prerequisite for life. This then leaves us with one question. How did Earth get its water? We have two theories on this question. The first one is the internal source that suggests that early Earth had an atmosphere dense in hydrogen gas, and this hydrogen somehow reacted with hot magma from the Earth's surface to form water. Then, the external theory suggests that water came to Earth from space after the planet formed and some comets dropped on the planet. Well, it is not entirely verified. Maybe one of you someday can help us with that. My thinking suggests that a combination of these two theories might be the most likely scenario. So, now that we know how scientists discovered that liquid water is the only prerequisite for life, we will now try to answer the question why the liquid phase is so important. We'll break that question into two and start with why liquid. Let's revise the three states of matter to answer that question. The three typical states of matter are solid, liquid, and gases. Figure 1 shows us the how molecules are packed in each phase. In solid, the molecules are arranged in a regular pattern and are tightly packed together, but they can actually vibrate. In liquid, the molecule can move around and slide past each other. And then in gas, the molecules have no order and they are just randomly colliding with each other. So we know that the main purpose of life is to create life, and that is done by passing on genetic information from one generation to the other generation. So molecules in solid state are too ordered and molecules in a gaseous state are too chaotic, and these conditions cannot pass on genetic information. So, however, in a liquid state, molecules are not too chaotic or too ordered. They are just about right. So the liquid phase might just be ideal for supporting life. But why is this? This is because liquids allow for reproduction and serve as a medium for genetic information to be passed on from one generation to the next. In the solid phase, the genetic information would almost take forever to pass on the information. The gaseous phase is just too chaotic to be passed on, for information to be passed on from one generation to the next. So the liquid phase is just ideal. So now we have established that the liquid phase is necessary for passing on genetic information. Now we are going to answer the other parts of the question, why water? We'll be looking at the unusual chemical structure of water, which gives water unique bulk properties. Let's revise some chemistry on the outstanding properties of water to be able to answer that question. Water is a colorless and odorless inorganic compound with the chemical formula H2O. Figure 2 shows the chemical structure of a water molecule that consists of two hydrogen atoms and one oxygen atom. Here we can see a red circle representing the oxygen atom that is connected to two white circles representing the hydrogen atoms. The bond between the hydrogen atom and the oxygen atom is called the covalent bond. Covalent bonds are chemical bonds that involve the sharing of electrons to form pairs between atoms. The covalent bonds hold together the hydrogen atom and the oxygen atom of one individual water molecule. So, in a water molecule, electrons are not shared equally. Now, that is because oxygen is more electronegative than hydrogen. Oxygen always wants to receive more electrons. So, it starts pulling a little more on the electrons it shares with the hydrogen, making the hydrogen side to become slightly positive and the oxygen side to become slightly negative. Now, because of this uneven sharing, there is a creation of a special attraction between water molecules that form a bond called a hydrogen bond, and causing the shape of the water molecule to become bent. We can define the hydrogen bond as a bond formed between big electron receiver like oxygen and a small element like hydrogen. So here's what happened. We get positively charged hydrogen side and a negatively charged oxygen side. Also, since opposite charges always attract each other, a hydrogen bond forms between a hydrogen atom of one water molecule and an oxygen atom of another water molecule. The hydrogen bond only happens between two water molecules. So, the hydrogen bond and the unusual bent structure of water give water unique properties which make it very good at making our planet habitable and supporting life. Now that we know where the unusual chemical structure of water comes from, let's look into some of the properties that make water very good at making our planet habitable. Have you ever stirred salt or sugar into a glass of water? If yes, then you have witnessed a unique chemical property of water, which is water as a universal solvent. Water is often referred to as a universal solvent because it can dissolve a wide variety of polar, non-polar molecules and ion compounds such as salt, lemon juice, or baking soda. All that is because of the positively and negatively charged end of water molecule. To illustrate, let's consider the salt and water example. Let's look at the illustrations on the top left of the screen. On the left side, you can see a salt that is being poured into a glass of water. And if you stir it, you can see the salt molecule to start breaking up into sodium and chloride ion. If you stir salt into water and you look at figure 3, it shows us a salt molecule represented by the blue circle that represents the sodium ion and the chloride ion that are represented by the green ion, and the water molecule that is represented by the red circles. So what happens is when a sodium chloride or salt molecules are poured into water, the sodium chloride particles will begin to break up and form sodium ions and chloride ions. Water molecules will interact with these ions and form hydration shells around each ion, where the positively charged hydrogen ions bond with the negatively charged chloride ions, and the negatively charged oxygen ions will bond with the positively charged sodium ions, just like magnets, where the opposite charges start to attract one another. Another interesting property of water is surface tension. If you take a toothpick and carefully place it on the surface of a glass of water, if you can see properly, the toothpick is not sinking, but it is starting to float on the surface of water. That is possible because of water high surface tension. The surface tension refers to the tendency of a liquid surface to act like a stretched elastic film. So if you look at figure 4, it shows the surface tension of water, and the green area represents the surface area of water, the blue circle representing the water molecules, and the white circles representing the hydrogen bond. The toothpick is able to float because the hydrogen bond is just slightly stronger than the force that the toothpick is applying on the surface of water, but not so strong to hold the human weight. So more energy is required to break this hydrogen bond, and the toothpick does not have that type of energy. The high surface tension of water causes water molecules to hold closely together and form an invisible film. That is why small insects like water striders can also walk on water. So let me give you a small illustration. This is what happened. Let's consider this as two water molecules. Without the hydrogen bond, these two molecules, anything can pass between them. But with the hydrogen bond, they now hold together, and it makes it so hard for you to pass through. So water also has the highest capacity of any liquid except for mercury. So the specific heat capacity is the amount of heat or energy needed to raise the temperature of 1 gram of water by 1 degree Celsius. Let's imagine this. You take Limpopo heat and sun, you bring it to a Cape Town beach. In a hot summer day, we usually run from the sand and go cool off in the water. That is because more energy or heat is needed to heat the water than it is needed to heat the sand. This is because lots of energy is needed to break the hydrogen bond that holds the water molecules together. So far we have learned why water is the only prerequisite for life, and we also learned about the unique properties of water that make our planet Earth to become habitable. You are probably asking yourself, with the amount of water that we use every day, how come we always have running water and clean water? Well, that is possible because water is always recycled through the earth system via the hydrological cycle. So this process makes water special because it is continuously recycled through the earth system. The steps involved are evaporation, condensation, and precipitation. So this is what happened. Surface water is evaporated from the oceans, from lakes, and any surface water by the sun's energy. Water vapor then forms clouds in the sky as the evaporated water starts to cool down and the condensation process happens. Depending on the temperature and the weather conditions that day, the condensed water vapor now starts to fall to the earth's surface as different types of precipitation such as rain or snow. Some precipitation will flow downhill into rivers, lakes, and oceans as surface runoff. Other precipitation will sink into the ground and is stored as groundwater. Then water can evaporate again and form clouds and begin the hydrological cycle all over again. The hydrological cycle is so important because it enables the availability of water for all living organisms, and it also regulates weather patterns and on our planet Earth. So if you think about it, if water is always recycled, it means that we are drinking the same water that maybe dinosaurs were drinking or even our great parents. So just think about it. So let's do a bit of recap. We already know why it is so important to have water in a liquid form. It is because the liquid state allows for genetic information to be passed on easily. We also look into water unique properties, and these properties such as high specific heat capacity, high surface tension, and being a universal solvent, among many others of the that is because of the hydrogen bond that is formed when two or more water molecules are brought together. We also just discovered how water is recycled through the earth system to make sure that we always have circulating water through the system. Now, how does South Africa fit into all this? Well, let's answer that question now. Although South Africa is known to be a water scarce country, it is home to vast rivers and some of the largest rivers in Africa, such as the Orange River, the Limpopo River, and also the Vaal River. So South Africa also has vast oceans as with a vast coastline. Some oceans do meet and mix, and there is a warm on the Indian Ocean on the east coast and the cold Atlantic Ocean on the west coast. South Africa is also home to amazing water-based tourist attractions such as Howick Falls in KwaZulu-Natal, the Blyde River Canyon in Mpumalanga, and the water parks such as the Valley of Waves at Sun City in the Northwest Province.